right? Prove that the homogeneous equation of second degree ax square plus 2hxy plus by square equal to 0 represents a pair of straight lines passing through the origin. This is important theorem. Yes, we have to prove this. Firstly, we have given ax square plus 2hxy plus by square equal to 0, where b does not equal to 0. Then dividing both sides by x square, what will you obtain? If we divide by x square, here will be a plus 2h xy over x square plus by square by x square equal 0. Dividing by x square, or simply we can write b times y by x whole square. These terms I have taken here, plus here x cancel, 2h y by x plus a equal to 0. This is this equation, which is quadratic equation in y over x, ax square plus bx plus c equal to 0, that is y by x. It is quadratic in y by x. Here also y by x whole square, ax square and x square plus bx plus c equal to 0 form. It is developed by y by x. So this is quadratic in y by x. Therefore, if this is quadratic equation, it has two roots. Yeah, we will obtain two roots. So simply y by x equal minus 2h plus minus 4h square minus 4ab all by 2b. You know the quadratic equation is if ax square plus bx plus c equal 0 given, the value of x are minus b plus minus root under b square minus 4ac by 2a. Comparing this equation with this equation, the x of the variable is y by x and minus b is minus 2s and plus minus, and b square is 2h whole square, that is 4h square minus 4ac. For a is what? B, and c is a, so it is 4ab by 2a. A is b, that's why it becomes 2b. So simply what is y equal minus 2h plus minus root under 4h square minus 4ab over 2b times x, or this times x. This means homogeneous equation equation of second degree in x and y represent a pair of lines given by y equal m1 x and y equal m2 x. Here I have written here, this means y equal minus b plus minus 4a for b square minus 4ac by 2a times x. This is so if we have taken one root this value as m1 as a positive, it becomes y equal to m1 x, and if you have taken negative one, that is m2 times x will be y equal to m2 x. So where we have to define that, where m1 is equal to what, minus h. If you may ask why minus h. Yes, if I have taken 4 common here, and that will be cancelled with denominator and this, yeah. So minus h plus minus root under h square minus ab by b, this is m1, and m2 simply means sorry, not plus minus, here is plus sign, positive one, and m2 is minus h minus root under h square minus ab by b, this is m2, because these two and common two of this radical sign will be cancelled, and we'll obtain the value of m1 and m2 is in this way. Now moving to the next part, thus we get two lines. This and this, through the origin. Passing through the origin, that is y equal to m1 x and y equal to m2 x. Represented by the equation first, that at the beginning we have given the equation. Yes, here I have mentioned equation first, that is this, okay, represented by the equation first. Now if b equal to 0, yes, we have supposed b does not equal to 0. If b equal to 0 from equation first, what will you obtain? ax square plus 2hxy equal to 0. If b is 0, we will obtain that, okay, in the first equation. Then for ax times, if x is common, ax plus 2hy equal 0. Either x equal to 0, that is y-axis, or ax plus 2hy equal to 0, which are also two lines passing through the origin. So here the main point is, in the first condition what we have discussed, let me highlight once. We have suppose b does not equal to 0 and divided both sides by x square, and it goes in the quadratic form of y by x, and using this formula x equal minus b plus minus b square minus 4ac by 2a, we find y equal to this solution, this times x, while taking 2 common from this radical sign and from this 2 and this cancel. Then this means homogeneous equation of second degree in x and y represent a pair of straight line, because if x is 0, y also becomes 0. This may be m1, and we have suppose m1 is minus h plus root under h square minus ab by b, and m2 is minus h minus plus for m1 and minus for m2 we have taken. Then we get two lines passing through the origin. We have to continue the relation. We indicate some nodes. Which we have discussed earlier, what is m1, and we have already defined m2 are real only when h square greater or equal than ab. Number 1, m1 and m2 are real only when h square greater or equal than ab. As we have discussed earlier, m1 equal minus h plus root under h square minus ab over b, and m2 equal minus h minus root under h square minus ab by b. So m1 and m2 are real only when h square is greater or equal than ab. The value within a radical sign may be 0 or may be positive when h square is greater or equal than ab. So we'll get real roots only when h square is greater or equal than ab. Firstly, we have to go through this. If we obtain this, thus ax square plus 2haxy plus by square equal to 0 represents a pair of straight lines passing through origin only when h square greater than ab. And the note number 2 is, as I have shown, m1 in this and m2 is this. m1 and m2 are real and distinct if h square is greater than ab, and coincident coincident if h square equal ab, and imaginary if h square less than ab. From here you can see, if these two are equal, minus h by b, and here also minus h by b, will get an real root if that is positive, imaginary root that is negative. If that is equal, we will get same slope. That's why they are coincident. If h square equal to ab, m1 value is minus h by b, m2 value is also minus h by b, which is same. That's why they are overlapping or coincident, or that's the same slope. Yeah. And Next part, note number 3, m1 plus m2 equal minus h plus root under h square minus ab by b plus minus h minus root under h square minus ab by b. While taking b common, minus h plus h square minus ab minus h minus root h square minus ab. Then this can be cancelled, minus 2h by b, and therefore m1 plus m2 is minus 2h by b. Similarly, m1 dot m2 equal to, in the same process you can find a by b. It is very important part for this also. So plus m1 plus m2 is minus 2h by b, as I have shown here the solution. m1 times m2 is a by b, that a square minus b square formula you can apply, and finally you will get this solution. Now moving to the next part. Next part is condition of general equation of second degree represent a pair of straight lines. Condition of general equation of second degree to represent a pair of straight line. We have to go through it. Here the general equation is x square plus 2hxy plus uy square plus 2gx plus 2fi plus c equal to 0, where a does not equal to 0. This may or may not represent a pair of straight lines. A pair of straight line sometimes it may represent a curve too. So it represents a pair of straight lines only when the following condition hold. The condition to represent a pair of straight line is firstly, the condition to represent a pair of straight line by this equation is that is quadratic equation in x, quadratic equation is x, and it gives 2 roots px. And firstly we have to modify this is ax square plus 2h y plus 2g x plus by square plus 2f y plus c equal 0. This is quadratic in x. Now the value of x equal minus b is this term 2hy plus 2z plus minus 4b square. B square is 4 times 2 is common, then it will be hy plus 2z hy plus g whole square. B square is this minus 4 a itself a and c it is this is c by square plus 2fy plus c all this over 2 times a. It gives 2 roots. Yeah, now then by taking 2 common we can write here minus 2 times sy plus g. Here from this 2 4 is common, then radical sign is out. We can remove the radical sign for 2, then 2 here, then hy plus g whole square minus a times by square plus 2fy plus c all over 2a. Then if we have to cancel this 2 and this 2, minus sy plus g plus minus root under hy plus g whole square minus 8 times by square plus 2fy plus c all over a. The general equation of second degree may represent a pair of lines if the quantity inside the radical sign is perfect square. This is the radical sign. Inside the radical, this term should be perfect square. As I have already mentioned you that it should be the perfect square, otherwise we will not get the real roots. Yes, second may represent a pair of lines if the quantity inside the radical sign is perfect square. That means sy plus g whole square minus a times by square plus 2fy plus c is perfect square. Then a plus b whole square we can apply h square g square plus 2 hyz plus d square minus aby square minus 2a of y minus ac is perfect square. Just I have opened this bracket, that should be a perfect square, or this is y square, this is y square, hy is this, h square y square is this, 2hyz plus g square minus this, and this terms we can take common, we can change into what terms of y square, that is h square minus ab y square, and we have to change into quadratic form of y square, and then plus here is y, here is also y, we can add these two terms, that is 2h g minus 2af y plus here is g square minus ac, g square minus ac, this is also perfect square, this is also perfect square. Then this equation is perfect square if both of its roots are equal. Yeah, so suppose that the example is x square minus 25 square 0 x equal plus minus 5. This is not a perfect square, but x minus 5 x minus 5, that is x square minus 10x plus 25, this is x minus 5 whole square, this is perfect square, but this is not perfect square, so both the roots should be equal. Yeah, same and equal. Yeah, so that's why to be a perfect square, this in terms of y square, we have to judge that b square minus 4ac, that is b square minus 4ac equal to 0. If it is 0, then what will happen, that minus b x equal minus b plus minus b square minus 4ac by 2a, this is working not, I have shown. Then if this term is 0, then minus b by 2a, both root will be minus b by 2a, that's why it will be the perfect square. Okay, if this term is 0, then we will get a perfect square roots. Yeah, now dear students, let's move that. In this condition, h square minus aby square plus 2hg minus 2afy plus g square minus ac is a perfect square only when for b square minus 4ac equal to 0. b square, what is b square? Our b square is, this is b square, yeah, 2 times hg minus af whole square minus 4, what is a, simply h square minus ab, h square minus ab, and what is c, g square minus ac equal to 0. I think I make you clear. Then you can apply this whole square for hg minus af whole square minus 4 whole square minus 4 h square minus ab square minus ac equal 0. This 4 is taking common and dividing 0, we will obtain 0 result in that case. So we can apply a minus b whole square here. H square g square minus 2h g af plus a square f square minus 4 is already gone here. This is h square and g square is h square g square. H square minus ac is minus plus minus minus h square ac plus minus minus g square ab plus minus minus plus a square bc equal 0. Then dear students, we will be getting now let's check here bc ab ac h square g square h square g square. It can be cancelled here. It can be cancelled. Here a square f square three 4 5 6 7, yeah. Then let me check. Now dear students, let me copy these ones. Minus 2s gf a plus a square f square minus h square g square minus minus plus h square ac minus minus plus g square ab plus minus minus a square bc equal 0. This cancel. Now this term is minus a square bc minus this term is 2 af gh and this is plus a square f square plus now this term is CAH square plus this is G square AB. 1 2 3 4 5. These two cancel. 1 2 3 4 5 terms are equal here, and in all terms there is a so minus a is common. If we have taken minus a common, here will be a b c and here will be 2fgs. It will be plus minus minus 2fgh. It will be minus a f square because one a is common, and this is also minus minus a is common ch square, and here a is common minus bg square equal 0. Therefore a does not equal to 0, so this term is 0. So abc plus 2fgh minus af square minus ch square minus equal to 0. This is the required condition to make general equation of secondary represents the pair of straight line. This is the condition. You have to remember this formula: abc plus 2fgh minus af square minus ch square minus bg square equal to 0. This is the required